Good morning, students, and welcome to Systems of Equations on this super cold day. It's going to be about 18 degrees out today, and that's the high. And then it's going down to 7. So let's warm up with some algebra. Today we're going to talk about solving systems of equations using the elimination method. First, we do have our do now prompt where we're talking about making a change. And I love that question. I think you'll enjoy it too. Our objective is to solve systems of equations using something we call the elimination method. So our central question asks, what are the 4 steps to solving a system of equations using elimination? So we're going to complete 4 problems in our assignment, but we're going to be doing some problems on the whiteboard. So please be ready to take some notes on that as well. So for our exit ticket, we will review those 4 steps to solving a system of equations. And for homework, we've got homework 5.3. I only want you to complete problems 1, 2 through 8. We are making this a 2-day lesson. There's a lot to this, but it's kind of like fitting a hand in a glove. It's putting that puzzle together, and when you see it works, it really is quite satisfying. And using the Desmos online graphing calculator, which is just beautiful, we can actually see our results and check our answers to make sure they're correct. You know what to do to get full participation credit, especially have that camera during our initial discussion. You respond when your name is called at the beginning, middle, and end of the period. And make sure that you submit your completed lesson. Actually, you had asked me if we can go till 8 o'clock the next day. So let's just say Saturday morning. So I'll change the due date on that. Okay, if you have any questions, please send an email. So we're not doing late turn-ins. We're practicing turning in our work on time, getting ready for high school. And we are practicing, you have to do this work as it is assigned. If you let it go, you're not going to understand the next skill we do. So let's get third quarter off to a really good start by just continually doing our work as it is assigned so that we don't get behind. Our map testing will be the 4th and the 5th of next week. It will start. So let's put our do now question, very colorful today. Throughout history, people have spoken up and started movements to bring change. Examples include the civil rights movement, women's issues, animal rights, bullying issues, and many others. Sometimes change can take many years. Why should we work to change things if we can't solve the problem in our own lifetime? Why should we bother to start that work? I want you to think about that, and I want you to answer right here. Remember, if we don't start that work now, that work may never get done. And that work, whatever issue that's important to you, will always be an unbegun work, not just an unfinished work, but it will be a work that was never started. So sometimes you really have to start something on faith. I may not get this solved in my lifetime, but I can start to put change into effect. And that's what a lot of great leaders that have gone before us have done. So I want you to please think about that question. Why should we work to change things if we can't solve the problem in our own lifetime? So we'll come back to our exit ticket later, where we review those 4 steps to solving a system of equations using the elimination method. But for now, I want to take us to our whiteboard. So we're solving a system of equations using the elimination method. Here we are. So what is it? Solving systems by elimination is a method for solving systems of equations by adding or subtracting to eliminate a variable. Okay, we're adding or subtracting in order to eliminate one of the variables. So what are the steps? The first thing you want to do is to make sure that the equations are lined up. So you'll see what that means, but it's just like when we're young and we first started learning how to add and subtract, especially when you started learning how to add and subtract decimals. Your teacher told you how important it was to line those up. The second step is to add or subtract the equations in order to eliminate, to make it go away, to make one variable go away. And it's going to be the variable with common coefficients in today's examples. The third step will be to solve for the remaining variable, because remember, if you have two variables and you eliminate one, you only have one left, and that's the one you'll solve for. Now, maybe you'll eliminate y and you'll solve for x. And then the last step, substitute, use parentheses, folks, your answer into either original equation, either one, and solve for the other variable. Now, these instructions don't make a lot of sense to us until we actually try to do a couple of problems on our own, and then they start to fall in place. So let's start with our first example. We have 6x plus 5y equals 4, and then we have 6x minus 7y equals negative 20. Well, I notice that I have 6x in each one of these. If I subtract the second equation from the first equation, I can easily eliminate this 6x. 6x minus 6x cancels each other out. So what we have left is, now remember, we're subtracting a negative. So subtracting a negative is the same as adding a positive. So we end up with 5y plus 7y, which equals 12y. 12y equals, again, subtracting the negative is the same as adding a positive. So 4 plus 20 equals 24, and then we divide both sides by 12, and y equals 2. Now, that was step 1 and step 2. Now we need to solve for the remaining variable. We're going to, we did that. We're going to do step 4, We solved for the y. Now we're going to substitute our answer into either original equation. Now, take a look at those equations. It doesn't matter which one you pick, okay? You can pick the first one. You can pick the second one. I'm going to pick the second one, so I'm going to write 6x minus 7, and now I have y equals 2. So I'm going to substitute, instead of y, I'll put 2, our substitution. And then the rest of the equation equals negative 20. Okay, so let's multiply here. 6x minus 14 equals negative 20. Let's add 14 to both sides of the equation. And 6x equals negative 6. And we'll divide both sides by 6. And x equals negative 1. So our ordered pair, negative 1, comma 2. Okay, let's check this out on Desmos, okay? There's our 6x plus 5y equals 4. And here's our 6x minus 7y equals negative 20. And indeed, the solution is the point negative 1, 2. Desmos is a great way to quickly check your work when you do these systems of equations. All right, let's do one more example. So we've lined them up. Now we need to either add or subtract in order to eliminate a variable. When I look at this, I have negative 3x here, and I have a positive 3x here. So I'm just going to add these two together. If I add them together, the x values go away, and I'm left with 4y minus y, which is negative 5y, And -1 plus -4 is -5. And of course, when I divide both sides by -5, y equals 1. Now I'm just going to insert 1 into one of these equations, and I think I'll use the second equation. Just looks easier. So 3x equals, okay, so I'm going to substitute 1 where y was. So finish writing the equation. So 3x equals negative, oops, I put a equal sign instead of a subtraction sign right there. There we go. Perfect. Okay, 3x minus 1 equals -4. So I'm going to add 1 to both sides. 3x equals -3. And if I divide both sides by 3, x equals -1. So my ordered pair, -1, 1. And again, let's check that out on Desmos. So it was -3x minus 4y equals -1, and 3x minus y equals -4. And here's our ordered pair. They intersect, and the solution to that system is -1, 1. So let's go to our work page, and let's continue our work here. Okay, so first of all, what are we doing? What is it that, what is this elimination method? It is a method for solving systems of equations by adding or subtracting to eliminate a variable. Okay, so make sure the equations are lined up. Then add or subtract the equations to eliminate the variable with the common coefficient. Coefficient is the number that the variable is being multiplied by. Then we're going to solve for the remaining variable and then substitute your answer into the original equation and solve for the other variable. So let's do these problems. So I see I have y equals 3x plus 4 and y equals x minus 2. So I'm just going to subtract the second equation from the first. So y minus y is 0. You don't need to put the 0 there, but I think it's helpful, and I'll show you why. So 0 equals 3x minus x minus, we have an invisible 1 here, minus 1x is 2x. Now here, remember, subtracting a negative is adding a positive. So 2x plus 6. This makes it, we have that 0, it's kind of a holding place. So it helps us when we subtract 6 from both sides, we're isolating 2x. So we have -6 equals 2x. And then we divide both sides by 2. And x equals -3. Now I'm going to take the -3 and put it in one of the original equations. I like this equation here. It's nice and simple. Small numbers are better numbers. So I'm substituting, instead of x, I'm going to put that -3. I was hoping to use a different color there. Okay, that's my substitution. So -3 minus 2 is -5. So y equals 5. My ordered pair is -3, -5. Let's check out Desmos. And here we are. Y equals -3, -5. I mean, the equation solution equals -3, -5. And that's our ordered pair. So let's go on, keep solving. We have x plus 4y equals 13, x minus y equals 3. For this particular problem, I think I'm just going to subtract the second equation from the first. Sometimes you can put parentheses around it if that helps you. So x minus x eliminates the x's. Now we have subtracting a negative, right? Subtracting a negative. So that makes this positive. 4y plus 1y is 5y equals 13 minus 3. We are subtracting is 10. Divide both sides by by 5, and y equals 2. I'm going to put that 2 right into the second original equation. X minus 2 equals 3. There's my substitution. So I will add 2 to both sides so that I can isolate that x, and x equals 5. So my ordered pair is 5, 2. And I believe I may have graphed this. X equal x plus 4y. Nope, I did not graph. Yeah, I did. X plus 4y equals 13. X minus y equals 3. And there's our solution right there, 5, 2. Okay, great. So let's go back, keep solving. And go back to Desmos for a minute. Let me see what I'm doing. Okay. There we go, number 3. So I've got 3x minus 10, y equals 14, 3x minus 9y equals 15. I'm just going to go ahead and subtract the second equation from the first, so the x's are eliminated. Now remember, we are subtracting a negative, which is the same as adding a positive. Negative 10y plus 9y is negative 1y, or negative y. That's an invisible 1. 14 minus 15 is negative 1. Negative y equals negative 1 means we have to divide them both by 1 to get rid of the negative, and then y equals 1. So I'm going to insert y into, I'll choose the first equation. So the y value is 1. 3x minus 10. Instead of y, I put 1 equals 14. Let's distribute this. 3x minus 10 equals 14. We'll add 10 to both sides. 3x equals 24. When we divide both sides by 3, x equals 8. So we've got an ordered pair of 8, 1, and I think we graphed this one. Yep, sure did. Let's turn these two off. 3x minus 10y equals 14. 3x minus 9y equals 15. And this is going to be a hard one for us to pinpoint, but there it is. I think maybe if I expand the graph a little bit, it might be easier for you to see that point. There it is. They do cross. The slopes are very, very close to each other in this one, and that's the beauty of Desmos. You get to see that. But they are not, this is not an infinite solution. These definitely cross. All right, let's go back to our paper. last problem of the day, and then we'll review those steps. So I'm going to subtract. Look at this. I'm not going to work with x's. I want to eliminate the y's. So I'm going to subtract the second equation from the first. This one's a little tricky. So 2y minus 2y, these will be eliminated. Remember, subtracting a negative. So 4x minus negative 2x is 4x plus 2x, which is 6x, equals 6 minus 18 is negative 12. We divide both sides by 6, and x equals negative 2. Now, I'm going to go ahead and put this negative 2, I'm going to substitute it for y in the first equation, 4x plus 2. Instead of y, I'm going to insert this negative 2 equals 6. The first thing I'll do is this distribution, 4x, and then negative 2, positive 2 times negative 2 is negative 4. So 4x minus 4 equals 6. Let me see, did I copy that right? I just want to double check. Oh, I know what I did wrong. Look what I did, students. I substituted for y. Silly me. Let me redo it again. See, even the math teacher makes mistakes. Okay, 4 instead of x, negative 2 plus 2y equals 6. Now I distribute. So negative 8 plus 2y equals 6. Add 8 to both sides of the equation, which gives us 2y equals 14. Divide both sides by 2, and y equals 7. So our ordered pair is negative 2, 7. So let's review those steps. So make sure the equations are lined up. Oh, that does not show up very well. I need a different color. Super important step. Okay, add or subtract to eliminate the variable with common coefficients. Okay, then solve for the remaining variable. And finally, substitute your answer into either original equation and solve for the other variable. It doesn't matter which one you choose, always choose the easiest. Okay, so that's it, solving systems of equations by elimination. We'll be doing this over the next 4 days or so. So you will get lots of practice, but you know how it works. As you practice, you become great.